Running. Coaches are interested in understanding which factors most influence a runner's 10K race time. The dataset was collected from 40 amateur runners, recording factors such as weekly training hours, sleep hours, number of rest days, daily hydration, race day temperature, and years of running experience. Conduct the appropriate hypothesis test to determine which variables significantly predict total 10K race time. Use an alpha of 0.05. All right, so let's look at the data. So lots of columns here. And remember, Y is still in the first column, and that's 10K race time. Obviously, lower times are better. In terms of hydration, that's measured in ounces, temperature in Fahrenheit, and experience measured in years. Okay, so let's go ahead and start the data analysis toolpack. Pick regression. Now, you'll notice that if you've done a previous problem, these ranges already come pre-populated. That can be a little bit dangerous because these data sets are different lengths on different tabs, so always redraw. So click here, and you notice this one comes up short because this is a longer data set than the previous one we did, so make sure you highlight everything. And same with the X values, notice that that comes up short. Okay, and then the output range, that's also going to have to change to that spot right there. Everything looks good. Remember, while it's still highlighted, switch to number, and then we'll look at the p-values. And so we start with the biggest one. We're actually not sure for this 0.05 because we'd have to go to more decimal places to see if that's over or under the 0.05, but we're not going to worry about that one yet. We're looking at the 0.31, which is clearly over. So that's the first one to go, and that's rest days. So we come back to our model, and we've got to get rid of rest days. That's right in the middle, so we'll delete that column. And by the way, another way to do this instead of deleting columns would be to copy it again and then delete the column there so you don't remove your original data, but try to make this as easy as possible. And remember, only two things change now. That's going to be the X range and the output range. So let's do the X first. It's got to contract by one column. And then let's click on this guy for the output range. And that's going to be down here. Click OK. Remember, while it's still highlighted, back to the Home tab. Change it to number. All right, now let's look. Okay, and this is kind of interesting because remember the number that we were a little suspicious of, the 0.05 previously, now became a 0.06. The reason that happens is because the items interact. And so when you eliminate one, then you get some unexpected interaction effects. So this value actually got boosted. And that's also why we do one at a time, because we know that we may have some interaction effects down the road. Okay, so that is sleep hours, which has to go. So let's come back to our data and data. Oh, wait, I actually have to get rid of it. So delete sleep hours. There we go. And then let's go to data analysis, regression. And so the Y range stays the same. The X range has to change, contracts by one column. And the output range now moves down. Click OK. Remember, while it's still highlighted, go to the Home tab and choose Number. And as you can see now, everything is statistically significant. So while this is still highlighted, we'll copy it, come back here, paste in the final model, and then we can copy the values over to the final model coefficient table. So equals coefficient for the intercept equals p-value for the intercept equals coefficient for training equals p-value for training equals coefficient for, oh, well, sleep is gone. So that's going to be NA rest days is gone, so that's NA2. And we're up to hydration. Equals coefficient for hydration equals p-value for hydration equals coefficient for temp equals p-value for temp equals coefficient for experience equals p-value for experience equals standard error for the whole model. All right. Now, as far as our regression equation, that's going to be equal to the intercept, which is locked, plus training hours, which is also locked, times training hours here unlocked, plus, okay, well, sleep hours and rest days don't figure in, so we jump all the way to hydration, locked, times hydration not locked, plus temperature locked, times temperature not locked, plus experience locked, times experience not locked. There's our regression equation. So that's our prediction with this data. So we then, remember, our prediction could be off. So it equals this value minus 2 times standard error locked. And then over here, it's equal to the predicted value plus 2 times the standard error locked. Highlight all three, copy it down. And we are good to go. Notice again, 66.3 is the intercept value. In other words, when all the predictors are 0, you'd be left with 66.3, which is kind of meaningless, but that's the way it works. All right, what's the interpretation of the slope for experience? Negative 1.94. And that's going to be for each additional year of experience, predicted 10K time decreases, because it's negative, by 1.49 minutes. So that's good, right? You want your time to come down. What's the interpretation of the intercept? And that's going to be B. It's not meaningful. What's the interpretation of the slope for hydration? And it's for every 1 ounce, remember, hydration is measured in ounces, for every 1 ounce increase in daily hydration, race time decreases, that's why it's negative, by 0.24 minutes, holding all other variables constant. So when hydration's good, helps get your race time. So experience is good, hydration's good. And the slope for training, negative 2.4. Again, negatives are good because we want decreased race time. And that's going to be C for each additional hour of training. They predicted 10K race time decreases by about 2.4 minutes, holding all else constant. So, in other words, training's good. So as you actually look at these predictors, right, training's good, reduces your race time. Hydration's good, reduces your race time. Experience is good, reduces your race time. The only one that actually increases your race time is the temperature. Those, if it gets hot, not good. Right? We had here the temperatures. So as the temperatures go up, then the runner's going to get hot. Their race time is going to decrease. All right, using the experiment row. So we're going to fill that in. Training at 6. Hydration at 75. Oh, these are out of order. That's okay. Temperature at 72. And experience at 3. What's the estimated 10K race time? So remember, these two aren't filled in because those are NAs. And that's going to end up in a prediction of B, 49.3 minutes. And what's the correct regression equation? Okay, so that's going to be one that does not include sleep or rest. But none of them do, so so it doesn't help us eliminate. So what we're going to be looking for is which ones get the sign right or wrong. So all the signs are negative except for temperature, which is positive. So this first one can't be true because notice that's positive on training. This one would work. So these two would work for training because they're both negative. So it's going to that limits us to B and C. Negative on hydration. That's good too. Positive on temperature. That's good. But notice that this one has a plus on experience, but experience was negative also. So it has to be C because C has experience is a negative. In other words, experience reduces your race time. What's the interpretation of the standard error? On average, predicted race times differ from actual by 3.08 minutes. And which variables were statistically significant in predicting 10K time? All right, so that was everything except sleep and rest. So it's training, hydration, temperature, and experience. Training, hydration, temperature, and experience. That's B. Sweet. Okay, now for the other tabs here, on this assignment, we're going to challenge you to do those yourself. But we can talk about it a little bit. So this one is shorter, has fewer predictors. So this one is managers want to understand which factors most influence daily sales at a clothing store. So sales is what's being predicted. And a data set was collected for multiple store days, including foot traffic, average basket value, and average checkout wait time. And so here's the data for that. Foot traffic, average basket value, and wait time in minutes. We're trying to predict daily sales. And you can kind of think about it. Try to always think about these problems in sort of, practical terms. One would expect foot traffic would increase sales. One would increase average basket value, would increase sales. But one would probably expect that wait time, right, as your wait time goes up, customers have to wait, that might actually decrease sales. This one's on orders. Analysts are interested in understanding which factors most influence order fulfillment time and hours. Data set was collected from 50 recent online orders, including order size, number of items, distance to customer, warehouse staff on shift, inventory availability, system processing delay, and order complexity. So kind of an interesting problem. Lots of potential values. And this is what influences order fulfillment time in hours, right? So what do we really want? We want that time to go, from a business perspective, we want that time to go down. In other words, we want to fulfill orders faster. So we're hoping for variables to be significant that lower the fulfillment time. So fulfillment is how long it takes them to process the order, to complete the order. So good luck with those two problems. If you run into trouble, then please send your Excel sheet or Excel workbook to your professor, indicating what you're having difficulty with, and we will try to help you and give you feedback.